Welcome to my channel, Math with Nazia. In this channel, you will find a lot of tips and tricks across all the topics in math. So, in this video, we are going to learn about closure property of a whole number. So first, let's see what's the closure property states. The closure property states that when you perform an operation such as addition, subtraction, multiplication or division. So any of these operations if you're going to use on any two numbers in a set. So what is the meaning of a set? A set means either a whole number, an integer or any type or natural number, anything. So first today we are going to learn about whole number. So let us keep as a whole number. So on any two numbers in a set, the result of the computation number in the same set. So the result of the computation number also should be in the same set. That means if you're going to take a whole number, when you add two whole number, the answer should be a whole number. That is actually a closure property. Or when you subtract two number, your answer should be a whole number. Right. Same way, when you multiply two whole numbers, your answer should be a whole number. When you divide two whole numbers, your answer should be another whole number. So I think you all know what is a whole number. A whole number is nothing but it starts from 0. It starts from 0 and all the positive numbers are called whole numbers. Clear? Whole number is nothing but it starts from 0 and all the positive numbers are called whole numbers. So now let's see how does this closure property works on addition, subtraction, multiplication and division. So let's see our first property. Whole numbers are closed under addition. So as I told you, there are four operations. We are taking the first operation, which is addition. So let's see whether the whole number are closed under addition. Let's take a very easy example of a very small numbers. Like let me take it as 3 plus 4. So what is 3 plus 4? 3 plus 4 is nothing but 7. So 7 is also a whole number. So 3 is a whole number. 4 is a whole number. When I added these two whole numbers, I got a whole number. Right? So when you add two whole numbers and you get another whole number, then that is a whole number is closed under addition. So your question and the answer should be a whole number. Let's take another example of 5 plus 2. Again, this is also again 7. So 5 is a whole number, 2 is a whole number, and 7 is also a whole number. So now we can say that whole numbers are closed under addition. So this is true for addition. So whole numbers are always closed under addition. We have learned our first property. Now let's take our second property. Whole numbers are not closed under subtraction. So here they have given whole numbers are not closed under subtraction. So for subtraction, let's take few examples and see whether it is closed or it isn't closed. So let me take an example. 5 minus 3. So 5 minus 3, what is our answer? It's 2. Now as you could see, 5 is a whole number, 3 is a whole number and 2 is also a whole number. So we could say that it is closed under subtraction because everything is in subtraction. But what it actually tells us that it should be the same case for every number. In case, I'll give you another example for subtraction. For example, you have a number 3 minus 8. So 3 minus 8, what do you write? 3 minus 8. What is our answer? Which is negative 5. So negative 5 is not a whole number. So we have a whole number minus a whole number which is not a whole number. So in this case, it is not closed under subtraction. So usually when you see a property, it has to be universal. It has to be universal for every number, every whole number. But when you see this case, you have got the answer in the negative. So negative numbers are always called as an integers. So it is not a whole number. So it is not closed under subtraction. Clear? For few numbers it works, but for few numbers it isn't working. So whole numbers are not closed under subtraction. So this doesn't work for whole numbers for subtraction. Now let's see the third property. Is written as whole numbers are closed under multiplication. So here they are telling for whole numbers under multiplication are closed. The closure property works here. So let's try with an example. We have 2 times 3 which is 6. We have 5 times 4 which is 20. So whole number works here. So whole numbers are closed under multiplication. So however, whichever number you multiply, you get the answer as a whole number. 2 is a whole number, 3 is a whole number, 6 is also a whole number. Similarly for this example also. So whole numbers are closed under multiplication. Now let's see the fourth property. Whole numbers are not closed under division. So here they have told already that they are not closed under division. Let's see some examples. See, here also it should be universal. See, for some example division works and for some example it doesn't. Let's see some few examples. So for example, if I have a number 8 divided by 4, which is 2, and you could see everything is a whole number. It works here well, right? Now let me take another example as 7 divided by 3. So I got right 7 by 3. So this is a fraction number. It's not a whole number. So universally it doesn't work on division. Clear? So the whole number is not closed on under division. So now we have learned all the 4 properties, closure properties on whole number. So we have already learned that whole numbers are closed only under addition and multiplication, but not under subtraction and division. So now I think this closure property is very clear. Read the definition and understand with an example. This is a very easy closure property. And if you have any queries, any doubts on this property, you can comment down in the comment section. And I hope this method was easy for you to understand this topic. If you found this video interesting,